Hi there, fourth graders. Welcome back to Ready, Set, Read. As you know, I'm Miss Graves, and I am so happy to be here with you again today. On today's episode, we will continue learning about the rock cycle. But before we get started, make sure to gather all of the materials you need so that you can be successful with our lesson today. You are going to need your Week 4 Distant Learning Packet, a pencil, or a pen. If you write in pen, that's okay. And of course, some scrap paper. So go ahead and get that. I'll give you 10 seconds. Let me see if you can get it done in 10 seconds or less. I'll give you a quick countdown. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Did you get your materials ready? Great. Let's start our lesson. As I said, today we will continue our study of the rock cycle by reading another section of geology, the study of rocks, and answering questions from the text afterwards. The section we will read today is all about the rock cycle. But before we dive into our text, let's watch a quick video to introduce us to the rock cycle.
Have you ever looked at a rock and wondered how it came to be? The story begins about 4.5 billion years ago, as gas and dust come together to form the rocks that make up our planet. Created from elements forged far off in a galaxy, rocks really are the stuff of stars. And so are we. Rocks, and the minerals they're made of, tell us the story of our planet. Look closely. Atoms are the building blocks of all matter. Combined, atoms form molecules. Minerals are made up of billions of molecules, which are often arranged in crystal structures. Minerals can crystallize from semi-molten rock called magma. When magma cools and solidifies, it forms igneous rocks, one of the three main rock types: igneous, sedimentary, and metamorphic. Granite is an intrusive igneous rock, commonly found on the Earth's continents. It has large crystals because it cools slowly, deep below the Earth's surface. When a volcano erupts, lava cools quickly to form small crystals, creating extrusive igneous rock, like basalt. Basalt makes up much of the ocean floor and also most of the moon. Over time, rocks are broken down by weathering effects like water, wind, heat, or ice. Small fragments, known as sediments, wash into lakes, rivers, and the sea. Here, layers of sediments compact and cement together over millions of years to form sedimentary rocks, like sandstone. Limestone is another kind of sedimentary rock. It can form from the remains of marine organisms or from chemical reactions within sediments. Fossils in limestone are an amazing record of the past, revealing clues to changes of climate and the extinction of life forms throughout the Earth's history. Did you know the ground beneath your feet is constantly moving? The continents and oceanic crust are pushing, pulling, and sliding in a process known as plate tectonics. This heats and squeezes rocks, changing their form. Minerals realign or recrystallize to form metamorphic rocks. Slate, used in roof tiles, and marble are examples of metamorphic rocks originally laid down as shale and limestone. The way rocks and minerals change gives us a guide to their origin. A rock's size and shape, and the colour and arrangement of its minerals, help geologists distinguish between different types of rocks. Many layers of rocks create a section, like this. With practice, you can read a rock section like the pages of a history book that goes back billions of years, almost to the beginning of the Earth's history.
Wow, that video really sparked my interest in the rock cycle. I can't wait to learn more about it from our text, Geology, the Study of Rocks. Today, we are going to read and answer questions to help us better understand the rock cycle so that we can respond to our text-focusing question. Why are there different types of rocks and how are they formed? All right, we are ready to start reading the text. So I will give you a few seconds now to turn to the text in your packet so you can follow along with me. So look for your text in the packet, and while you're doing that, I'm going to tell you a quick story about why I love fourth graders so much. I love fourth graders because when I was in the fourth grade, I was not a very good reader, and I struggled with reading so much. But now look at me, reading to you, which is something I love to do, read to children. So you may not be a strong reader right now, but if you follow the strategies and if you want to be a good reader, or if you just even follow the strategies, you are going to be a rock star reader. Get it? Rock star, because we're studying about rocks. You really are, after this unit, you're really going to be a rock star. So, hopefully you have found the reading in your, or the text in your packet, and I am going to begin reading. Chapter 4, the rock cycle. The Earth is constantly changing. Major events such as volcanoes and earthquakes and even erosion may seem random. These changes are all made up of a pattern. However, the pattern is called the rock cycle. Rocks and minerals are created, destroyed, and renewed. Some events in the cycle occur over millions of years. Other events, such as volcanic eruptions, occur quickly. Geologists divide the rock cycle into 3 basic stages. Each stage creates a certain kind of rock: igneous, sedimentary, and metamorphic. The stages can be happening at the same time at different places on the Earth. Igneous rocks. One stage in the rock cycle creates igneous rocks. Igneous rocks begin as magma. In certain locations deep inside the Earth, temperature and pressure are just right to melt rock into magma. Some magma travels to the surface through volcanoes. After escaping the volcano, the magma cools very quickly. Some magma rises toward the Earth's surface but cannot escape the crust. This magma cools and hardens anyway. Because it is not exposed to the cool air at the Earth's surface, the process takes thousands of years. Magma might harden quickly or slowly. Either way, hardened magma becomes solid igneous rock. Fourth graders, make sure that you are paying attention to the text features in the text to help you understand the text better. Settling into sedimentary rock. As plates collide, some rocks are pushed up into mountains. At the same time, erosion wears down those mountains. Erosion also wears down volcanoes and igneous rocks. Wind and rain carry the soil and rock particles away. They are deposited into valleys, onto lake beds, and on the ocean floor. When eroded pieces of rock are moved into a low spot in the earth or ocean, they begin to pile up. This process is called deposition. Dead plants and animals might also pile up with the soil and rock particles. This layer of material is called sediment. As more and more materials pile on, the weight presses the lower layers of sediment into solid rock. The solid material created in this stage is called sedimentary rock. Look at the beautiful limestone in the picture Isn't that beautiful? Make sure you're paying attention to the text features on this page to help you understand the text better. Metamorphic rocks under pressure. As the sedimentary layers build up, the deepest ones come under intense pressure and heat. This can also happen to igneous rocks located deep beneath the Earth's crust. The pressure and heat change the chemical makeup of these rocks. Their minerals are forced to change or morph into other kinds of minerals. As they change in this stage, they turn into metamorphic rocks. Heat and pressure can also change one kind of metamorphic rock into another. The rock cycle continues. Rocks caught between two colliding plates can sometimes be slowly pressed downward. As they move closer to the mantle, they experience more of the mantle's intense heat. They may also be involved in chemical reactions that occur only at plate boundaries. The heat and chemical reactions melt the rocks into magma. The magma collects and some of it travels to the Earth's surface. It cools and hardens into igneous rock, beginning the rock cycle again. Fourth graders, make sure you're paying attention to the text features to help you understand the text better, which is the headings, the captions, and the diagram and the pictures. Now that we are finished with our first read, I think we're ready to answer questions about the text. Turn to the page in your packet that looks like this. I see directions at the top. Before we do anything, we need to read the directions first. The directions tell us first and foremost we need to answer each of the questions below. We need to use complete sentences and pay attention to grammar and punctuation. And we need to use evidence from the text to support our answers. I wonder what a good strategy would be to answer these questions best. Let me think. Well, great readers go back in the text when they are answering questions about the text. Using evidence from the text makes our answers stronger because it shows exactly how we know that answer. We will use this strategy as we answer each of the questions for this activity. I will show you how to use the strategy to answer the first question, and then you will be on your own. Ready? Here we go. Okay, so our first question is, what is the rock cycle? Why is the rock cycle important? Watch how I use the great reading strategy of going back into the text to find evidence to support my answer. This question is asking me about the big ideas of the rock cycle, which makes me think I need to go back to the beginning of the text where the author introduced the rock cycle. So I'm going to turn back to those first two pages. In your packet, you will see this part of the text next to the question to help you focus on finding the answer. So let's take a look. What does the text tell us the rock cycle is? Let's read the text. I'm going to reread the text for you. So listen out for what the rock cycle is and why the rock cycle is important. Here I go. The rock cycle. The Earth is constantly changing. Major events such as volcanoes and earthquakes and even erosion may seem random. These changes are all part of a pattern, however. The pattern is called the rock cycle. Rocks and minerals are created, destroyed, and renewed. Okay, I think I reread enough evidence to answer my question. Right. So, the rock cycle is the pattern of rocks and minerals being created, destroyed, and renewed. Oh, or constantly. Remember that word from our vocabulary lesson? The word constantly, meaning ongoing. Okay, so now I know what it is. Now I have to know why it's important. So it's important, let me see, because the text is telling me that the rock cycle is constantly changing and shaping the earth through major events like volcanoes and earthquakes and even erosion. Okay, so that's why it's important, because it's constant. Yeah, that's pretty important. If it's constantly changing the shape of the earth because of events like volcanoes, earthquakes, and erosion, wow, the rock cycle is a big deal. Just like fourth graders. Fourth graders also are a very big deal. So now that I went back into the text, I got my evidence to support my answer. Let me write it down. I said the rock cycle is the pattern of rocks and minerals being created, destroyed, and renewed over and over again. And it is important because it is constantly changing the shape of the earth through major events like volcanoes, earthquakes, and erosion. So what did you notice me do when I answered the question? What were some of the things that you noticed that I did when I answered the question? Think about it. What did you see or what did you hear me doing when I answered my question? Yes, I'm glad you noticed. I went back in the text to cite evidence to support my answer. I also reread the text, and I also underlined the evidence that I found. Great job, fourth graders. All right, now it is your turn to answer the question using the reading strategy that we just went over. For this question, make sure that you go back into the text to cite evidence to support your answer. And go back and make sure you read the text, reread, okay? Like you can reread more than one time. I usually have to reread things like 3 times before I really get it. So there's nothing wrong with that. This question is, what are 2 ways that magma can become igneous rock? What are 2 ways that magma can become igneous rock? I'll give you a hint. Go back to the page that you read about that talks about magma. All right, so I'm going to give you 3 minutes to answer this question using the strategy that we just went over. Go for it. You can do it. Go for it. Great job, fourth graders. I used my great reading strategy and went back into the part of the text that talked about magma to answer this question. By using this skill, I was able to answer, what are 2 ways that magma can become igneous rock? I wrote, magma can travel to the surface through volcanoes as lava and then cool and harden. Magma can also cool and harden in the crust, but this happens over a long period of time. Both of these processes create igneous rock. Take a moment to check your answer against mine. Give yourself a pat on the back if your answer had the same information. But give yourself a pat on the back even if you tried, because that's okay too. Now there are 2 questions left that you are going to answer on your own after our episode is over in a few minutes. Find those 2 questions in your packet. You got it. Great. And don't forget, when you write your answers, remember to use your great reader strategy of rereading the text to find evidence for your answers. You got this. You can do it. Fourth graders, thank you so much for joining me again today. I'll see you later this week when we are ready to start writing in response to what you read about the rock cycle. In the meantime, I know you can answer these last text-dependent questions on your own and continuing with your work this week because you're doing a great job. All right, bye.